Hello everyone, welcome back. Today we have this equation 2 to the power a plus a equals to 5, and let's try to solve it. Before we go any further, just note that here we cannot use any elementary function that we learned back in high school, which are square root, logs, or exponentiation. We cannot use that here. We can use graphical method where we plot the function of y equals to 2 to the power a plus a and y equals to 5, and their intersection is our solution. But what if you don't want to use graphical method just to solve this equation, but you want to solve it algebraically? What you must do is to use what we call Lambert W function. It says that Lambert W function of something multiplied by e to the power something equals to something a. So the Lambert W function is useful in solving equations where a variable appears both in the base and exponent, just like here. Let me just give you some few examples. If we have a Lambert function of 0, this is just 0. If we have Lambert function of e, this is just 1. Why? Because we have 1 and 1, and using this statement, we know that this will be equals to 1. And what if we have a Lambert function of minus e to the power minus 1? This will be minus 1 because we have minus 1 here and minus 1 here. And we have e. And let's do another example. What if we have a Lambert function of 2e2? This will give us 2 because we have 2 and 2 here. So let's generalize this. Whenever you have a Lambert function of something to the power something, this is equal to something, you must have e here. So let's solve our question. We had this question, and let's solve it. The first thing that you want to do is to separate 2 to the power x and x plus x. To do that, we have to subtract both sides by x. Now we have to divide both sides by 2 to the power x. We'll have 1 equals to 5 minus x. We know that 1 divided by 2 to the power x is just 2 to the power negative x. Recall that if we have a Lambert function of a, where a can be any number, and e to the power a, this is just a, we keep a. So in order to use this here, we have to make the exponent of minus x be equal to 5 minus x. The way that I'm gonna do this is to multiply both sides by 2 to the power 5. So we'll have 2, because we are multiplying 2 to the power x and 2 to the power 5, which the bases are the same. We keep the base and add the exponents. 2 to the power 5 multiplied by 1 is just 32. So if you check here, we have a similar structure. We have a base which is the same as the exponent of 2, but we do not have e. So somehow we have to turn 2 into e. The way that I'm gonna do this is to say 2 is equals to e ln 2. So whenever you have e and ln, this get rid of each other and you'll be left with 2. So I'm gonna use this. So I'm gonna have 5 minus x 2 is equals to e ln 2, all bracket to the power 5 minus x equals to 32. So this will be e to the power 5 minus x ln 2 equals to 32. And then because we have the power which is 5 minus x multiplied by ln 2, which is not the same as 5 minus x, we have to change 5 minus x by multiplying by ln 2. What we do in the left hand side, we have to do in the right hand side. So we can see that from here we can apply the Lambert function, because the base is equal to the exponent of e. So if we apply the Lambert function, we will have in the left hand side, we keep the exponent or the base in this, which is 5 minus x ln 2. From here, in order to find x, we have to divide by ln 2 both sides of our equation. If we solve for x, we'll have 5 minus w, which is a Lambert function, you can leave this this like this as our solution, or if you want, you could go further and use product log calculator to find w of 32 ln 2 divided by ln 2, which will give you x equals to 1716 as our solution. But if you want, you can leave this here as our solution.